Hello, welcome to the second tutorial in my programming series for the FTC programming. We're going to get into some very basic Java programming for in FTC and Android Studio. So if you sort of just left off where we were last tutorial, you'll be at this op modes folder. So this thing is called a package. It's kind of like a folder in Java, and it holds files called classes. And classes are programs that can essentially run things for you. And the class themselves have functions in them that do the actual lines of code that you're running. The actual structure of Java is pretty high level and fairly complicated, and I will probably not do it justice. If you want to go more in depth into Java and how it's structured, I would suggest like the Barron's AP book or some online things to actually research what these things mean and what they are doing. But I'm only giving a very sort of superficial explanation of what they are. So let's go into the situation where you want to create a new program. So you want to create a very basic Teleop program for your robot with 2 drive wheels and nothing else. What do you need to do? Well, first things first, you right-click op modes and you create a new Java class, because that's what we want to do. The Java class is the actual program. The Java class contains the program that we run to actually control the robot. And then you can name it whatever you want. So let's just name this Teleop tutorial 1. So the name can't have any spaces, so it's sort of convention to have underscores instead of spaces. And then just hit enter. Now right now, this won't really do anything. And there's a few things that we need to do in order to get it working so that we can actually plug in a controller and get it to read our inputs. So if you open Kane Teleop, you can kind of see what the structure is here. And they've got a lot of extra stuff that is very necessary to actually run the code. So let's just start at the beginning. The first thing you need to do is you need to go to this first line of public class Teleop tutorial 1, and we're going to have it extend another class. And extending another class just means that we're basically copying that entire class into this new one we made, so we can sort of edit parts of it to do what we want. And that's just what the Teleop is. We're sort of copying all the code that Qualcomm wrote for handling the controllers and the sort of Wi-Fi Direct, and we're sort of copying it into our own, and we're editing it so we can say, push a button, move my motor. So to do that, you just type in the words extends. You want to make sure you're doing it before this squiggly bracket. You're going to have it extend op mode. And op mode is the class that Qualcomm wrote. So right now, it's not recognizing it because we need to do something called importing, which basically means it just tells it where exactly op mode is. And importing is very easy. As you can see, Android Studio is telling you to press Alt and Enter. So if you just hold Alt and press Enter, it will automatically import it for you. And it is still red because there's still a lot of things you need to fill in here. And the first thing you need to fill in is something called a constructor. And the constructors aren't particularly important right now, but basically the constructor is sort of what happens when an instance of our program is created. So you don't have to actually do anything with it. It just sort of needs to be there. So just type in public and then the name of our class, which is Teleop tutorial 1, and then some normal brackets like that, so open close, and then squirrely brackets, and I like to hit enter and have some space in there just because formats. The other thing we need to do is we need to put in some of these functions. So they're overriding something. They're doing something called overriding, which basically means that init is a little function, and a function is just a piece of code that does something that can be ran over and over again, and it's just a nice thing to have. Basically, we're rewriting what init does. So init, in the original op mode that we're sort of copying, it doesn't really do anything. And so we need to have it do something. So to do that, you type in @override, and you can sort of see there's a lot of suggestions already. And these suggestions are super helpful. They fill in a lot of the code for you. So if you go down here, you can see public void init, and we want to override the initialize function. So if we just double click that, it will fill in the code for us. And you'll notice we're still getting the red, we're still getting the error, and if you actually read the error, it must be declared abstract or implement abstract method loop in op mode. So basically it's telling us we also need to override the loop function. So it's going to be exactly the same as init, and init is the initialize, and loop is the thing that runs over and over again. So basically checking for your controller inputs and seeing if you're pressing a button or moving the joystick, and then the robot reacts accordingly. And you want that in a loop running over and over again because you want to continuously be controlling the robot. You don't want it to stop. So we do the same thing that we do for override, for init. You override, and you just go to loop. And now it's happy because we overrode the loop function. And there's another function that's usually good to override, and we don't really use it. It's the stop function. It's just been sort of convention to override the stop function. So type in override and then stop. And then you can keep in the super.stop, or you can leave it or delete it. Super.stop doesn't actually do anything, and I don't really need to explain what it means right now. So you just delete that. Alright, so right now our program has a working structure. It will compile and it can run on our phone. It just won't do anything because we haven't written anything. So on a robot, what you need to do is actually declare and define what motors you have. And you need to do that in the program so it knows exactly where to find it and it knows how to handle it. And this is pretty simple to do. All you need to do is you need to declare something called a variable, which is basically a programmatic representation of something. It can actually be anything. It can be a number, it can be a word, it can be a car, and it can get fairly abstract. So you can have a variable that represents a car, or you can have a variable that represents a motor. And different types of variables, so like a car could be a type of a variable, a number can be a type of a variable, can do different things. And we're going to create a motor variable type. So what we're going to do is we want it to be public, so everything can see it. The word public just means everybody can see it. And we want all of our programs to be able to see the motor. So we're going to type in public DC motor. And whenever you see these little suggestions come up, you can actually program super fast. So I'm just going to hit enter and get DC motor. And I'm going to call it my right, because I'm going to say this on the right side of my robot. And then you're going to put a semicolon. What this is saying is there is some DC motor called right. I'm not going to tell you, what exactly it is or what it's doing. I'm just going to say that it exists. And this is fairly important for the program. And then we're going to do the same for the last motor. So just type in public DC motor left. And for the names, you can choose almost anything you want except for a Q keyword. So you can't call it public, You can't call it class. You can't call it import or package. There's a few keywords that you can't choose that are already being used by Java and the SDK, but the words right and left are perfectly fine. And it is case sensitive, so if you do a capital R, this will be totally different than lowercase r. So just keep that in mind. And naming variables is very important. You want to make names that make sense and that you can remember. So if you do something like, if you look at my actual code, this is a program that I used for this year. I have a whole ton of variables, and I gave them all I named them very specifically so that when I'm reading it, I know exactly what is happening. So when I see the word gyro, I know it's talking about my gyroscope, and I know exactly what is happening, even though I have like 20 different variables. So variable names are very important. So we've told the program that these things exist. And then we also now need to tell the program, where exactly the motor is plugged in on the controller. And what that allows us to do is that we're doing something called assigning it. So we're assigning it an actual value. We're giving the sort of theoretical variable motor of write a value into an actual physical motor. And so the way we do this is we go into the init, because this runs at the very beginning of every program, which is very nice, because at the beginning of the program, once we have our motors initialized, if we initialize them at the beginning, we can use them throughout the program. So to actually assign it a value, you just do write equals, and then the equal sign is just the operation of assigning something. So it is equals is an operation in programming. It's not sort of like a condition where I'm checking if write equals something or not, like in math, like 3 equals 2, that's definitely false. If I say x equals 2, I'm assigning x to the number 2. And so what we need to do to assign a motor is use some stuff that Qualcomm wrote for us that handles a whole bunch of USB and controller electronical stuff that's really complicated, but then Qualcomm just sort of did it for us. And this is just something you have to memorize. So you just do hardware map. You can sort of hit enter on the autos, on the sort of fill-in stuff. .DC motor, since we're declaring it as a DC motor. .get, and then you're going to put 2 little quotation marks to give it the name of the motor. And then this name is what you put on the configuration of the phone on the settings. So that's this name you get outside of this program. So it can actually be something different than the name of the variable. I keep it the same just to keep track, but you're going to set that on the phone. So what this line is doing is it's using the class hardware map, which basically handles all the electronics and the USB stuff. And that's the DC motor section, so we're only going to look in DC motors, and we're going to get the right motor and assign it to our right variable. And then one thing I didn't mention is make sure you have a semicolon after every line that does something. So you don't need a semicolon after this curly bracket, because this is just sort of a grouping of lines of code. It's not really doing anything, but like declaring a variable is doing something, assigning a variable is doing something. And so you just need to make sure you have a semicolon, otherwise it doesn't compile. So if I do like this, it gives me a little red line, and it's yelling at me saying, you don't have a semicolon, I can't compile. So just put that there. Alright, and then we're just going to do the same with the left motor. And then DC motor, and then we'll just say we called it left on the phone. Alright. So this is the entire init function. That's all we're going to put in there, because that's all we really need to do. Sometimes you might want to put in stuff like Like an autonomous, if your init function has, or the autonomous doesn't have an init function, but like in Teleop, if you want to like move your servos somewhere, or like get an arm out of the way so you can actually like roll around properly, you can put it in the init function. It'll just happen right away once you start the program. And so like at the competition, they'll ask you, do your servos move in initialization mode? This is what they're talking about. So once we've assigned those, we can go into the loop. And what the loop is basically the program will start at the beginning of the loop, run through all the lines in the middle, go to the end, and say, oh, I've reached the end. And since it's a loop, I'm going to go back to the beginning and do it all over again. So whatever you put, any lines you put in here will be running as basically as fast as it can, sort of go through the lines and then run it. And so you can put a bunch of stuff in here. What we're going to do today is we're going to say, if I'm pressing the A button, so the one sort of on the bottom of the button side, have the robot go forward. Otherwise, if I'm not pressing it, have it stop. So the way we do this, and I phrase that very specifically, because the word if is used in Java programming just as we would think as it's used in logic. And so the way we're going to do this is we're going to write if, and then two little normal braces, and then a squirrely brace, and then hit enter. And what this is doing is these swirly brackets are basically what's contained within this if statement. And then what's going to go into these normal brackets is the sort of condition. So if I say, if I am a person, that statement is true. And so anything I say after if I'm a person, then I have a conscious, then I have a conscious is also true if I am a person is true. And it works exactly the same in programming. So if I say if 1 equals 1, which is true, is going to run this code that's in here. And the reason I put two little equal signs is because, remember, when you use one equal sign, it's assigning. It's a function that assigns a variable to something else. And if you want to compare two things, like we do sort of like in algebra, we need two little equal signs to differentiate the two. So make sure you have two and not one, otherwise it'll kind of yell at you. And so how do we check that our game controller? So we want to say if I'm pressing the A button. How do I do that? Qualcomm has written classes that do that exactly for you. So they handle all of the different like USB codes that the controller sends, and it handles sort of the Wi-Fi communications with the controller to the robot phone. And so they make it really easy to check if the A button is pressed on controller 1. And the way you do that is you use sort of some keywords like we did before. So what you gotta write is gamepad 1, and these sort of showed up on the highlights already. Gamepad 1 is the first controller. And then dot, and then you just gotta find the A. And so you just type in A. And what this is referring to is the first gamepad. Look at the A button on that gamepad. And now the A button has some stuff after it, and then we can type in A dot. Oh no, we don't have to. Sorry. I was thinking of another function. Basically, what this will sort of say, gamepad1.a, what it's saying is if this button is pressed. So gamepad1.a is basically the representation of the A button on the gamepad. And so if it is pressed, this statement will be true. And if that statement is true, if the A button is pressed, this code will run that we put in here. Alright, so we're not going to put any code in there yet, because that's going into a few other things. And then the other thing I said that I want my program to do, so I said if I'm pressing the A button I want to drive forward, else stop. And so else is also a keyword in Java. And all you have to do is go onto the line with the closing swirly bracket on the if statement. And all you have to do is type in else. And then, as you can see, else is kind of a blue word. And then you put your swirly bracket and hit enter. And you don't need to have these parentheses in here because else doesn't need any parameters or sort of like clauses in it. So if I say, if this is true, do this, else, I don't need to say else this statement. I don't need to say else I am not a human. That's sort of assumed. It's just, if this is true, if this is not true, if this fails to run, do this anyways. Just sort of run this code in here. So we sort of have our structure here. If I press the gamepad A, run this, else run that. And so now we need the code for making our motors move forward. And the way we do this is we use our variables. And so I'm going to type in right. And what we can do to this variable is, this variable, since it's a motor, it can sort of do stuff on its own. So if I type in dot, sort of go into the variable, you can see a whole bunch of suggestions show up. And the one we want is, as the name suggests, set power. What this does is it sets the power from -1 to 1, and 0 being the stop of that motor. So just double click that, and then it says double power. What a double is that's another type of variable, sort of like how a motor is a type of variable. A double is a number that has decimal points. And this specific double has to be between -1 and 1. If you try to do something like 2, the program won't like you, and it will stop. And so we're just going to do 0.5. So we're going to run the motor at half power, which is safe. Alright, so we're setting our power for the right motor at 0.5. And now we have to do it for the left motor because we have two-wheel drive. So we type in left, dot, set power again. And then, so if we're setting the right motor to 0.5, positive 0.5, that means it's going to be turning clockwise. Now if you think of how motors are positioned on a robot, if both motors turn clockwise, it's not going to move forward. So what we need to do is set the left motor to go the opposite rotation of the right motor. So we're actually going forward because the left motor would be sort of flipped around. So we can do a negative number. We do -0.5. So this means that if gamepad A is pressed, I'm going to set the power of right and left to half and -half power. And so great. This is the first step of what we wanted to do with our program. Now, we also said else stop. And now stopping for these motors is just setting the power again, but not to half, but to 0, because the 0 is the sort of the break state. It will have the motor break. So we can do the same thing, dot set power 0, and left dot set power 0. And that's all we need to do. This will do exactly what we intended to do. If I'm pressing the A button, it'll go forward. If I'm not, else, it'll stop. And so this will just loop through and check. What this is doing is it's checking my A button every single time. It can loop through this as fast as possible and say, oh, you've pressed the A button, so I'm going to have the motors go forward. And oh, you're not pressing the A button anymore, I'm going to stop. And that's all I need to do to have the robot move forward just by the press of a button within Android Studio. And we don't need to do anything with stop. That's sort of handled by when you actually press the stop button on the phone. So that sort of handles everything. You don't need to put anything in here. if you really wanted to, you could put things in here. So like, if you when you stop the program and it dies, you want to make sure the robot has some servo inside of it, so it's not touching the ground at endgame. You can do that, and you can put it in here, and you can make sure that servo is sort of collapsed and your robot's all nice for scoring. So yeah, that's about it. Stay tuned for the next tutorial. We'll go more in depth with what you can do with these different variables and other things you can do that are a bit more complex. So yeah, thanks for watching.